So, in this class, we are going to solve ATP paper 6 of IGCSE 0625, variant 6.1. Okay, it's May June 2025 paper. Let's start with the first question. What they're asking, a student determines the density of a ball. This is a ball they have given. He places the ball between the two wooden blocks as seen from above. He take two measurements D1 and D2. Measure the length D1 and D2. Okay, whenever they are saying measured, it's mean you have to use scale. Okay, you have to take the reading practically. Okay, so I'm using scale here. You will put the scale like this, and D1, make sure your zero is on one side, and let me zoom in. Okay, so zero is there, and it's 2 and 2.5, and this is 2.6 that I'm getting 2.7. So D1 is 2.7 as you see. So it's 2.7 units are already centimeter. Now let's measure the D2. Okay. You have to exactly place where they have where they are making the arrows. Okay. So it's zero is on one side. I'm taking reading from the right side of the scale. Okay, there. So it's 2.1, 2.2, 2.3, 2.4 if you see closely. Okay, it's 2.4. It's near 2.5. It's more close to 5. Okay, so let's take it 2.5. So this thing is 2.5. Using your measurements, calculate the diameter d of the ball. Show you're working. Okay, if you see, this is the ball and you have taken the two readings of it. Okay, why we are taking two readings, from one is from the top, from one is from the bottom. We will find the average of it. Okay, so to find the diameter, the values you have calculated, you just have to take the average. So 2.7 plus 2.5 divided by number of the readings, that is 2, it will give you 2.6. So that is your answer. Moving forward, question part 3. Explain why this method is used to measure the diameter of the ball. Okay, so ball is of the round shape. Okay, so it's very difficult to find diameter directly. Let's suppose if you are going to find diameter, how you know? You have to place it here, here, here. Where you will place it exactly? So you don't know about it. So it's hard to measure the diameter. Or secondly, we know diameter always pass from the center, so we can't exactly tell where the center is at this point. If it is mentioned, then you can place the line and you can measure it, but there's no indication of center, so you can write down any of the point. I'm writing down hard to find center of ball. Or you can write it's difficult to measure diameter directly. Okay, to find center of the ball, that is why it is hard to find diameter directly. Okay, it's a 2 mark question, so I'm writing the explanation properly. Calculate the volume of the ball, and the equation is given. Okay, you don't have to act smart by using the volume of the sphere or something. They have given you the relation. So V is equals to 0.52 d cube. What is d? You have calculated above, that is 2.6 here. So it is 0.52 into 2.6, and you have to take the cube of it. It will give you 9.13. And you have to be careful, they're asking about the units as well. So volume is in centimeter cube, because d was in centimeter, so volume will be centimeter cube. For C part, the student measures the mass md of dish. Okay, what you have to do, he places the ball in the dish and measures the combined mass mc of the dish and the ball. Okay, shows the dish and the ball on the balance, record the reading. They have shown you the dish, they have shown you the ball, and they have shown you the reading. You just have to look at it and you just have to write down the value. It is 114.1 gram. Okay. Calculate the MB of the ball shown. Show your working. Okay. So what they are telling you, this is the mass of the dish, and this is the mass of the dish and the ball. So if you subtract both of them, you will get the mass of the ball. So what you have to do, mass of the ball, MB, is basically mass of the um, MC, dish and ball combined, minus MD. MC is 114.1 minus MD, that is 102.5. Do the calculation, you will get 11.6 units already given here. In part D, calculate the density of the ball using the equation. Equation is given. You just have to put the values. So density is MB is 1.6, and volume I have also calculated. Where it is? There it is. 19.13. So volume is, sorry, 9.13. Do the calculation, you will get 1.27. It's a 3 mark question and they're asking include the units. So mass was in grams if you see, and volume was in centimeter cube. So it will be gram per centimeter cube. Okay. So we are done with the first question. It's a 11 mark question. In question 2, this is from the thermal part. Okay. First one was from the general physics. This is from the thermal physics. A student investigate the cooling of hot water in a beaker. The apparatus is shown. The student uses a thermometer to measure room temperature. Room temperature is 22. Show clearly the reading on theta r. Okay, theta r, room temperature reading. So what you can do, you can, 22 will be somehow, if this is 20, this is 22. So you can mention it like this, 22. Okay. Or what you can do, you can fill it like this. Okay, it's your choice. You just have to mention where the 22 will be. So mercury will be seen like this. Okay. Moving forward, 22 degrees Celsius. Part B, the student pour 100 centimeter of water into an empty beaker. She records the temperature of the hot water and for 100 centimeter cube. Okay, without a delay, she pours 20 centimeter cold water into the beaker. Okay, first there is a hot water, and without delay, she is then adding the cold water. She stirs the water and measures the temperature of the mixture of the hot and the cold. She repeats the procedure until she added this much centimeter cube of the cold water to the beaker. All the readings are shown. What you have to do, complete the column heading. Complete the column heading for the 1 mark. This is the column heading. So they have given you volume is in centimeter cube and temperature is in degree Celsius. So it is centimeter cube. Most of the student mostly left this space unfilled. Okay. So whenever there is a table given, you have to fill the headings of it. Moving forward, plot a graph of temperature on the y-axis against the volume. Okay, so you have to take theta on y-axis. Theta is temperature, its units are degree Celsius, and volume on the x-axis, volume is centimeter cube. Okay, this is for the 1 mark. Okay, now what you have to do, you have to do the scaling. Okay, let me take this table down there so I can, so we can see it better. Okay, so let me, okay, so now we can easily do the working here. So this is the table we have. Okay, and we have to do the scaling. If you see what readings we have from 100 to 200. And how many boxes I have here? One, two, three, four, five, six. What the criteria is, you have to use at least 50% of this graph. Okay, so more than that, recommended is 75%. More than that is better, and you don't have to start from the zero. It's not mandatory. So what I can do for the scaling, I can start my graph from, I can say this point as 100, or I can name it, let's call this point as 100. This will be 80, this will be 120, this will be 140, this will be 160, this will be 180, and this will be 200. Okay, so don't take the scaling in the fraction form. Okay, it should not be like 107, 123. Okay, choose the easy scaling, that is in the whole numbers. So now for the y-axis we have readings from 49 till 87. This is the range. Okay, so I have to choose. Let's suppose we can, how many boxes we have? One, two, three, four, five, six. So I can take a gap of 5 or a 10. Okay, so if I take this thing as the minimum value is 49, so I'm not taking 49 as a starter, I'm taking 45 as a starter. So this can, I can take 55, this is 65, this is 75, this is 85, I have minimum, and this is 90. So it's covering all the values. Okay, so each box is equals to 1, so it's easy division. Okay, so let's move forward. What the first point is, first point we have is 87 and 100. So 87 is, if this is 85, this is 86, this is 87, so 87 will be this point, and 100 is, so it will be there. You have to make a cross or a dot, something. Then you have second reading, that is 120 and 73. 120 is here, 73 will be here. This is 75, this is 74, this is 73. It will be here. So we have to draw it here. Okay. Then the third point is 65 and 140. 65 is here, 140 is here, so it's exactly at this point. Then the next point is 160 and 59. 59. This is 50, 56, 57, 58, 59. 59 and 160, so it will be here. So 59 and 160. Okay, then the next point is 54 and 180. 180 is here, 54 will be one point below, so it will be here. And the next point is 49 and 200. This is 45, 46, 47, 48, 49, and this is 200, so it will be somewhere at this point. Now you have to draw a smooth line that is joining all the points, and it's very clear from the point that it will not be a straight line. Okay, if it's a straight line, mostly they mention in the statement above that you have to plot the best way to the straight line. Okay, so this is the best fit curve, it's not a straight line. So let's move forward. Part D, what they are asking. Okay, what is the mark distribution here? One mark is for this labeling, one mark is for this scaling properly, one mark is correct coordinates, and one mark is joining the straight smooth curved smooth line. Okay, in D part, in the experiment the student aimed to investigate the effect on the temperature of the hot water as the cold water is added. Complete the sentence to explain why it is important to add the cold water without delay at each stage. The cold water is added without the delay. Acha, they were telling in the question that she is adding the cold water without any delay. Why? Because if you delay, the temperature of the hot water will be changed. Okay, So what we want to do, why we are doing this, so temperature change due to cold water will be accurately calculated. Due to cold water can be measured. Otherwise, without adding the cold water, the temperature will be changed. Okay, so before loss of heat in surrounding. Okay. Next, second part. Complete the sentence to explain the reason for stirring the water at each stage. The student stirs the water before recording the temperature. Why we mix the water? To make sure each part of the water will have the equal temperature. So what we want to ensure the liquid have uniform temperature throughout. Okay, let's move forward. Part E. Suggest two ways to minimize the loss of thermal energy from the beaker during the experiment. Okay, we just have discussed before adding the cold water, the heat can be lost. So you have to make sure it will not be lost, or you have to minimize it. So what we can do, we can insulate. We can insulate the sides of beaker to prevent conduction. Okay. Then what you can do, we can add the lid on the top to prevent convection. We can add lid lid on the beaker. Okay, these are the 2 point. Or you can add, you can paint it with a white color or with a shiny thing, okay, to reduce the radiation or something. But two are enough. Name the apparatus that the student uses to measure the volume of the water. What we use measuring cylinder, okay, to find the volume. This is also a 11 mark question. Moving forward to the third question. Okay, so this question is from the light portion. A student investigate reflection in a plane mirror. A ray trace sheet is shown. So this is the ray trace sheet. What you have to do. Okay, what is the trick in it? You have to read the lines one by one, and you have to do it there. Okay, so I'm going to number them. This is, let's suppose, the one. Draw a normal to the line MR that passed through the center of MR. Label that as NL. Okay, so I have to first find the center. If I see this thing is, let me place 0 on one corner, this is 10 centimeter. So there is its center. Okay, so I have found the center. I have to draw a normal on it. So normal will be like 90 degree. You can see clearly on the scale. I'm going to choose 90 degree. Okay, so you have to draw the normal. You can draw a dotted line. Okay, like this. Call this N. Sorry, you have to call this thing NL. This is N and this side is L, let's suppose. Second point is label the point NL crosses MR with the point B. Now this is the point where it is crossing it, you have to label it B. Now third point, draw a line 10 centimeter from B at an angle of incidence 40 degree to the normal MR below MR. Okay, the line should be below MR and left of the normal. So if it is below MR, it should be in this region, and left, it's mean it should be in this region. So you have to draw the line there below and on the left. So, and its angle should be 40 degree. Okay, so 40 degree angle to the normal. Okay, they have instructed it very clearly. So Let me do it from there. What this angle is, this is 90. You can take the angle with a protector. I'm doing this with a scale here. So you have to take 90 and I have to take 40 degrees. So 90 minus 40 is 50. So it's on this digital measuring device. I can draw it like this. Okay. I guess they have, this is the 40 degree. I guess they have given the length of the line as well. This is, yes, it should be 10 centimeter. Okay, so you have to be very careful about all the instructions. So I'm going to place 0 on one side. Where is the 0? Okay, I have placed a 0 on the one side. It's okay, I have to extend it a bit. There it is. Now it is 10. Okay. Okay. And what we have to name it, label the end of this line as A. Okay, this end is A. Perfect. So moving forward, part B, this is for the 2 marks. The student places the reflected face of the mirror vertically on the line MR. He places two pins P1 and P2 on the line AB. Mark the position of P1 and P2 with crosses on line AB at the suitable distance. What is the suitable distance? It should be more than 5 centimeter. This is the criteria you have to keep in mind. For this type of ray trace experiment, label the position. Okay. So they should be 5 centimeters apart. So we don't need the scale here. I'm marking 1 point here, 1 point here. Okay, it does not matter. I know the full length is 10 centimeters, so I'm taking more than half of the length distance apart. So you can name this as P1, you can name this as P2. It should be more than 5 centimeter separation of P1 and P2. Okay, so we are done with the B thing. B, that's for the 1 mark. Moving forward to the C, what they are asking in C, the student views the image of P1, P2 from the direction indicated by the eye. He places two pins P3 and P4 so that the pins P3 and P4 images P2 and P1 all appear exactly one behind the other. The position are shown. Also, what they have given you the scenario that they have placed a mirror here. You can, this is some mirror. Okay, you don't have to draw it, just to give you a context. They have placed a mirror here. Okay, so what you have to do now, this is the thing that we have to do. Draw a line through the position P3 and P4. Continue the line until it meet MR. Okay, so continue the line until it meets MR. Okay, P3 and P4. The P3 and P4 are already mentioned. You just have to draw a line. They haven't told us how long it should be, so you can draw it of any length. I'm doing it like this. Okay, so there you go. I guess they haven't told, okay, they haven't told us that how much long it should be, so you can draw it anyway. The second part, this one we are doing, measure the acute angle alpha between this line and the horizontal MR, and acute angle is the angle less than 90. Okay, measure the acute angle between this line and the MR. This line is, they're talking about this line, and this is the MR. You have to measure this angle. Okay, so let's measure it. You can use the protector. I'm, this is 0, and when I bend this thing, or this is 1. Okay, okay, it's 131 or 132 almost. Okay, so this thing is basically on this digital scale that I'm using. This thing is showing 180 and this is showing 132. So 180 minus 132, it's giving me 48 degrees. Okay, so this angle is 48 degree as per our drawing. Okay, so this is called as alpha. If this is 48 degree, this thing will be 42 degree, that is almost equals to this thing. Okay, we will discuss this thing in the next part. In D part, this is 48 degree that I have got. Okay, the units are already there. Okay, the student turns the mirror through 180. He draws a new incident ray at an angle of incidence 50 degree to the normal above MR and left of the normal. Okay, so you have to do this thing now. First, I'm going to do this thing, then we will discuss this. Okay, so let's try to do this. The student turns the mirror 180, draw an incident ray at the left, on the left side, on this side, and on the top. So this is the way. There you have to, with the 50 degree angle to the normal. If this is, let me use my digital scale, this thing is 90 on the scale. So if I have to move 50 degree, I have to go there. It should give me 90 plus 50, it should give me 140. Okay, so this is 50 degree angle from here. You have to draw a line. Okay, so this is 50 degree. You can measure with the protector. They have called it I. Okay, and now let's move to the next instructions. This one we are going to try. He labeled the end of the line C. The line is not shown on figure 3.1. You may draw the line on the figure. Okay, this point you have to call C. Okay, and then again next part, he places two pins on the CB and view the image of the two pins from near top right hand corner of the ray trace sheet. On figure 3.1, draw a reflected ray 10 centimeter long from B with an angle of incidence beta equals to angle of incidence. Label the end as D. Okay, so what you have to do now, you have to draw the angle, the reflected ray. If this is 90, normal is 90, I am moving there, it should be, okay, so this is, okay, this should be for 10 centimeter, they have told us. So this point is 0, this is this, and there you go. Okay, it should be straight line. Okay, so this is incident ray, this is reflected, and this is angle beta, this is also 50 degree. Okay, and you have to call this end as D, that they have told us. Okay, so we are done with this part as well. This is for the 2 marks. Okay, so in the light ray tracing question, you just have to follow the instructions step by step. This is the key, that's it, and you can do the question very easily. If you try to do it all at once, if you try to read it and draw it all at once, there is a high probability you will do the mistake. In part E, suggest a relationship between alpha and beta. Justify your answer by reference to the result. So what they are equal. Okay, why they are equal now? You should be thinking. One was, if you remember, let me show you. Where is alpha? Alpha is 42, and beta is 50. So they are nearly equal. So you can write they are in limit of experimental accuracy. Okay, how you know what is the limit of experimental accuracy? You can say, okay, this is just for your knowledge, that if readings are in range of 10% plus minus 10%, they considered equal. Okay, so if you see, if you take value of 40, 10% of 40 is 4. So what is the range of the 40? 40 plus 4 is 44, and 40 minus 4 is 36. So any value between these 36 and 44 can be considered equals to this thing. Okay, so that is how you have to answer this question in ATP. State two techniques that you use in this type of experiment to obtain an accurate ray trace. Okay, what you are doing in this, you are placing the pins, you are drawing the rays, and okay, so what you can do, the pins you are placing, they should be thin, you can write down, the lines should be sharp, you can say draw, let me use the other pen, draw sharp lines. Okay, and or you can say the pins should be far apart, at least 5 centimeter. Okay, or you can say place the pins exactly vertically. Okay, it's your choice, you can write down any two of them. So let's move to the next, that is the planning question. You have to first understand the question very well, then you have to move forward. Okay, so let's try to decode it first. What they are telling us, a student investigate the relationship between the diameter and the resistance of the wire. So this is the theme of the experiment. He is investigating what, the diameter and the resistance of the wire. And this is the apparatus that you have. Other apparatus normally found in the laboratory are also available. Plan an experiment to investigate the relation between how the diameter of wire changes affects the resistance. Okay, so what you are changing, this thing, you have to choose it yourself. So this thing is basically the independent variable. The variable that you are taking by your choice is independent variable. This thing, the resistance, it will be changed because you are changing the diameter. So this is dependent variable. It's depending on the diameter. Okay. So resistance are, you have the formula in this that you have to use. You do not need to write down the precautions. These are the points that you have to cover: one, two, three, 4, 5 points. Okay, excuse me. So let's start with the question. We'll start with answering the question. First, you have to draw the diagram. So what you need to measure in this diagram, you have to change the diameter, and the diameter will affect the resistance, and you have to calculate the resistance by this formula: R is equals to V over I. So this is made by the voltmeter. So you need 1 meter of voltmeter, reading of voltmeter, you need reading of ammeter. Okay, this formula is also showing what will come in the table as well. Okay, so you have to draw the circuit diagram. So first, let's start with, um, we have power supply, so let's draw the power supply here. This is the power supply. Okay, you can draw the battery as well, and this power supply should have some ammeters installed in series, and there you have to place the wire. Okay, then this is the circuit. Voltmeter you also have to attach, so you can attach the voltmeter in parallel with the wire. Okay, so you have to label this thing. This is wire, this is power supply, this is voltmeter. This is a standard symbol of voltmeter, you don't have to mention it, but you can do if you want to. This is the ammeter. Okay, so this is the circuit diagram. We are done with the first thing. Second, explain how to do the investigation. Okay, now this is interesting. What you have to do, you can make the heading investigation. Let's solve it down there where the place is. It's for investigation. Okay, I'm making the heading properly. What we can do, first you have to measure the diameter because that was the independent variable. Okay, so what you use, we use micrometer screw to measure the diameter of first wire, because we are going to take multiple wires, right? Okay, when you are measuring the diameter, you have to keep in mind you have to repeat your readings. Okay, that is for the additional marks that is in this question. So what you will mention, take three readings, at least three readings at different points, at different positions, because it's not mandatory that the diameter of the wire is uniform. Positions along the wire, and calculate average diameter. This thing will give you additional mark. Okay, this is additional marks coverage here. Okay, then what you have to do, you have to write down, set up the operators of the circuit as shown. So you can say set up the circuit as shown above. Okay, we have missed one thing in the circuit. There should be a switch here. Okay, so I can, this is a switch. Okay, so set up the circuit as shown above and close the switch and record reading of voltmeter and ammeter. You get 2 meter. Okay, now in the next step, what they're asking, we have covered point 2. Okay, in third state, one key variable to keep constant. Now what you have to do, you have to repeat this thing with the different wire. You don't have to write on all of the things. You can simply say, for the third point, repeat the process. Which process? The above process. Okay, repeat the above process with, with wire of different diameter while keeping length same, length and material same. So this is what you are keeping constant. This will give you another 1 mark. Okay, so let's go back to what they're asking. The fourth part, what they're asking, you have to draw the table now. Okay, so you first, you have to write down, do this thing for, do this for multiple, do this thing for at least 6 wires. Okay, or do this for 6 wire, you can say. Okay, now you have to draw the table. When you draw the table, you have to look, first thing that will come, that is the dependent variable, that was diameter d, and its units are millimeter. And draw the table properly with the scale, straight line, as neat as possible. Okay, so it give the presentable look. Okay, so This is the diameter. Then the next thing is you're taking the reading of voltage and the current. So you can say voltage V slash V. Okay. Another column will come for the current. So current is I slash A. You have to write down the units as well, okay, in which you are measuring. Then you will get the marks. And last, you have measured the resistance. Symbol is R, units are ohms. So there you got the mark for the table. The last thing they're asking, the five. We're done with third and fourth. Fifth. Explain how to use your result to reach the conclusion. So what you can say, this almost fixed to each and every question, that plot a graph of resistance R on the y-axis against diameter D on x-axis to analyze their relationship. Okay, on x-axis there comes an independent variable, on y-axis there comes a dependent variable. That's it, you are done with the paper.